We're going to spend this video practicing composing permutations because that's going to be something really important to us. And what specifically we're going to do is we're going to take two permutations in disjoint cycle form and we're going to figure out the disjoint cycle form for their composition. So here I have two permutations S and T, which are elements of S8, the permutations of the set 1, 2, 3, 4 up to 8. And we're going to work out the product or composition S composed with T. And specifically, we're going to work out an expression for ST as a product of disjoint cycles. So sometimes people will call this a disjoint cycle decomposition. When they say that, they mean an expression for a permutation as a product of disjoint cycles. So how do we do this? You remember the procedure from our last lecture, which was we start off with any number which is not yet in a cycle, and we simply see where does it go under the permutation S composed with T. So we may as well start off with 1, and then we have to answer the question, what is S of T of 1? So S T of 1, that is S of T of 1. And T of 1 is 1, because 1 doesn't appear in the cycle T. And S of 1 is 5, so this is S of 1, which is 5. So the next thing in my cycle will be 5. Next, I need to know where S composed with T sends 5. So I need S of T of 5. This time 5 is in the cycle defining T, and T sends 5 to 4. So this is S of 4, and S of 4 is 2. So we go 1, 5, 2. And we can keep on doing this. So S of T of 2 is S of 2 because 2 is not in the cycle defining T, so that's 6. On the other hand, S of T of 6, well, T of 6 is 6 because 6 doesn't appear in the cycle T, and S of 6 is 1. So we've closed the cycle. 6 went to 1, and that means we stop writing this cycle, and we have to start again. So now we have to look and think, are there any numbers which aren't yet in a cycle? And there are. For example, 3 is not yet in a cycle. So we're going to start a new cycle and look what happens to 3. S of T of 3 is S of 8, because T sends 3 to 8. And S of 8 is 8. So we get a 3 and then an 8. S of T of 8 is S of 5, which is 4. S of T of 4 is S of 7, which is 7. And S of T of 7 is S of 3, which is 3 again. So we're back round in a cycle. So we close this cycle off. Again, we ask, are there any numbers left which aren't yet in a cycle? This time the answer is no. We're thinking about permutations in S8. And so we have all of the numbers 1, 2, 3, 4, 5, 6, 7, 8 here. So we're finished. We found our expression for S composed with T as a product of disjoint cycles. So as practice, what you should do now is do the composition the other way round, T composed with S. This will both A, give you practice in composing permutations and finding disjoint cycle decompositions for them, and B, will illustrate that S and T, S composed with T and T composed with S are in general different. So pause the video and do it. Okay, if you paused the video and you did it, what you should find is the answer is, or an answer is 1, 4, 2, 6, 3, 8, 5, 7. Like this. Let's put the commas in to be careful. And remember that there are actually lots of different ways to write this same answer. So if what you wrote doesn't look exactly like that, it doesn't mean that you're wrong. You know, you could have got 8, 5, 7, 3, 2, 6, 1, 4, for example. That is the same permutation. So as we saw at the end of our last video, there are many different ways to write the same permutation in a disjoint cycle form. Right, let's try one last example. So we're now going to compose 3 permutations in cycle form. And those 3 permutations are going to be called A, which will be the 2 cycle 1, 2, B, the 2 cycle 2, 3, and C, the 2 cycle 3, 4. You'll see why we're doing this in a video or so's time. So we want to know a expression for the composition ABC, which is 1, 2 composed with 2, 3 composed with 3, 4 as a product of disjoint cycles. So again, we follow our procedure, which is we pick a number, may as well start with 1, and we see what happens. So C sends 1 to 1, B sends 1 to 1, and A sends 1 to 2. So our composition sends 1 to 2. And again, let's think what our composition ABC does to 2. Well, C sends 2 to 2, B sends 2 to 3, and A sends 3 to 3. So 2 goes to 3. Next, thinking about 3, C sends 3 to 4, B sends 4 to 4, A sends 4 to 4, so ABC sends 3 to 4. And finally, if we look what happens to 4, C sends 4 to 3, B sends 3 to 2, A sends 2 to 1, so putting those together, ABC has sent 4 back to 1, which means we close the cycle, and that's it. We've dealt with all of the numbers 1, 2, 3, 4, which appear in our permutations, so ABC is equal to the 4 cycle 1, 2, 3, 4.